Hi Year 7 and welcome back to your Year 7 ALPS maths lesson. So today we're going to be looking at multiplying by powers of 10, something which you probably have done before and probably know a little trick to, but we're going to look at why it works. So by the end of today's lesson you should be able to define, so that means tell me the meaning of an integer. You should be able to show a friend or a family member how to multiply by 10, 100 and 1000. And hopefully some of you will be able to explain why we can't just add on the zeros, which might be the trick that you learnt in primary school. So the first thing we're going to do today is just have a look at some definitions. And what we want to do today is we want to look at how a number changes when we multiply and divide by 10, 100 and 1000. And we're going to look at division next lesson. So on the screen I have two blank spaces. The first one is asking for a definition of an integer. So can you explain the meaning of the word integer? And the second one says when we multiply a positive integer by 10, 100 or 1000, the number must get something. Pause the video and see if you can tell me the answer to those two blank spaces. Okay, let's have a look if you were correct. What did you say was the definition of an integer? What does the word integer mean? An integer is a whole number. Did you get that right? Well done. That means that it can have no fractions or decimals in the number. So 1.5 or 5.2 is not an example of an integer. So, when we multiply a positive integer by 10, 100 or 1000, the number must get what? Bigger. Did you get that right? Fantastic. Okay, let's have a look then how we can use some of these rules to help us multiply by 10, 100 and 1000. Here is my first example. I'm going to start by looking at multiplying by 10. So at the top it says multiplying a positive integer by 10. All of the digits move. The rule is that all of the digits move one place to the left because they're getting bigger. And if we have any empty spaces, do you know what goes in those empty spaces? It's called a placeholder, and that placeholder is a 0. Let's have a look at the first two examples. The first question says 42 times 10. And you'll notice underneath I have a place value chart. You should find in the lesson instructions I have put a place value chart on Jamboard for you. You can use that to help you answer the questions later in the lesson. The first thing I'm going to do is put my number 42 onto my place value chart. The 4 goes under the tens column and the 2 goes under the units column, just like that. If I multiply by 10, the rule says all the digits move one place to the left. So I'm going to move that 4 and that 2 one place to the left, making them bigger. The 4 is now under the hundreds, the 2 is now under the tens, but I don't have anything under the units. What do I need to put under the units column? That's right, I need to put a 0 for a placeholder. So 42 times 10 is 420. Let's look at the second example. The second example says 194 times 10. So I'm going to do the same thing. I'm going to put 194 in my place value chart. The 1 goes under the hundreds, the 9 goes under the tens, and the 4 goes under the units. To multiply my positive integer by 10, I move all the digits one place to the left. Whoops. There we go. So now my 1 is under the thousands, my 9 is under the hundreds, and my 4 is under the tens, but I don't have anything in the units column. What do I need to put in the units column to finish the number? That's right, I need another 0, another placeholder. So 194 times 10 is 1,940. Let's look at some slightly different examples. My next examples involve multiplying by 100. When I multiply a positive integer by 100, this time all the digits move 2 places to the left. And again, I need a placeholder of a 0 to put in any empty spaces. So my first number is 72 times 100. If I put my 72 in the right columns on my place value chart, I then move them 2 places to the left. 1, 2. And as I did on the previous examples, I'm going to put the zeros in the empty columns. This time, I need to use 2 zeros. I can put zeros in all the other columns apart from the decimal point, but I don't need to because it doesn't change my number. Let's look at the next example, 305 times 100. I'm going to put my 305 under the correct column headings and then move everything 2 places. 1, 2. And then finally, to finish the question, I'm going to put my placeholders of zeros in the empty spaces. So 305 times 100 is 30,500. That's a difficult number to say. My final example are going to be timesing by 1,000. Hopefully you've started to see the trick by now. When I multiplied by 10, everything moved 1 place to the left. When I multiplied by 100, everything moved 2 places to the left. So when I multiply by 1,000, what do you think I'm going to move? That's it, I'm going to move 3 places to the left. And as I have with the other questions, I'm going to use a placeholder of 0 in the empty spaces. So my first question is 38 times 1,000. I'm going to put my 38 in the correct columns, and now I'm going to move them 3 places to the left. 1, 2, 3. And I'm going to put my placeholder zeros in all the empty spaces. That means that 38 times 1,000 is 38,000. That's a pretty big number. My final example is 714 times 1,000. I put my 714 under the correct headings. I then move all the digits 3 places to the left. 1, 2, 3. And I put my 0 placeholders after the number. 714 times 1,000 is 714,000. That's the biggest number that we've had so far. So now it's your turn. In a second, I'm going to ask you to pause the video, go to Google Classroom and find Task 1, Multiplying Integers by 10, 100 and 1,000. Use your place value chart on Jamboard to help you make notes and move the digits 1, 2 or 3 places to the left using zeros as placeholders afterwards. Give yourself about 10 or 15 minutes to complete this task and then come back to the video. Pause the video now. Well done. I'm really looking forward to seeing your scores for task number 1. I'm sure when you learnt about multiplying by 10 in primary school, you learnt the trick of putting a 0 on the end. but that's what it is. It's a trick and not why it works. When we are multiplying decimals by 10, 100 and 1,000, this trick won't work. So we're going to use the rule that we have just learned. The rule for multiplying decimals is the same. If we are multiplying a decimal by 10, all the digits move one place to the left, and we put a 0 as a placeholder in the empty spaces. Let's look at our two examples. My first example is 3.4 times 10. As I did before, I put the number 3.4 under the correct headings on the place value chart. I then move each of the digits one place to the left, remembering that a number cannot go in the decimal point column. My 3 moves to the tens and my 4 jumps to the units. That means that 34 times 10 is 34. I can leave the point there, or I can simply delete it. My second example is 2.97 times 10. As always, I'm going to put my number under the correct place value headings in the chart. I then move all the digits one place to the left, remembering that my decimal point must stay in the decimal point column. My 2 moves to the tens column, my 9 jumps to the units column, and my 7 goes to the tenths column. 2.97 times 10 is 29.7. No zeros or placeholders in sight. Let's have a look at timesing by 100. The same rule as before. When I multiply by 100, all the digits move 2 places to the left, and we put a 0 in any empty spaces as placeholders. My first example is 0.49 times 100. I'm going to put the decimals under the correct column headings in my place value chart. I'm then going to move each of the digits 2 places to the left, leaving the decimal point where it is. The 0 moves to the hundreds column, the 4 moves to the tens column, and the 9 moves to the units column. I don't really need the 0 or the decimal point in this question, but it doesn't change my answer. 0.49 times 100 is 49. Let's look at the second example. 12.6 times 100. I first put the 12.6 under the correct columns on the place value chart. I then move each digit 2 places to the left. The 1 goes to the thousands column, the 2 moves to the hundreds column, and the 6 jumps to the tens column. This time I have an empty space under the units. What goes there? That's right, it's a 0 placeholder. We can get rid of the decimal, but it doesn't change our number. 12.6 times 100 is 1,260. Our final examples are timesing by 1,000, and just like before, when we multiply by 1,000, all the digits move 3 places to the left, and we put zeros as placeholders in the empty spaces. So if I have 35.173 times 1,000, those values go in there. And if I move each digit 3 places to the left, what number am I left with? Did you get it right? 35,173. I don't need the decimal point. 9.52 times 1,000 is slightly harder. I put this here, and if I move everything 3 places to the left, what do I end up with? Did you get that right? 9,520. Did you remember to put the place value holder of a 0 under the units column? So for your final task, I'd like you to go back onto Google Classroom and have a go at task 2, multiplying decimals by 10, 100 and 1,000. Hand your work in by Thursday at 3 p.m. Good luck!